All right, the first two of these are not as bad as you might think. Okay, so find the sum of the roots. How do we get the roots? The roots are the x value, so x is just equal to negative b plus or minus square root b squared minus 4ac all over 2a. So the first root would be, and then this is all you have, so you just have a, b, and c. You don't have any numbers to substitute. So you've got negative b plus the square root of b squared minus 4ac all over 2a, right? And then if you want to find the sum of that, you're going to have to add that to here, which is negative b minus square root of b squared minus 4ac all over 2a. So these have common denominators, so I can just add the denominators. So negative b plus negative b, that would be negative 2b. And then I have plus this part right here, the square root of b squared minus 4ac. And then subtract that same amount. That becomes 0, right? So this is just all over 2a. And when I simplify the fraction, it's just negative b over a. And similarly with the product of those roots. So so the same thing again. If I was to, I don't know if I can copy those. Yeah, maybe I can do that. So, well, I'll just rewrite them. So we got negative b plus square root of b squared minus 4ac all over 2a, right, multiplied by negative b, b squared, negative b, minus square root of b squared minus 4ac all over 2a. Okay, so this is going to be, think of this negative b is over 2a, and all this is also over 2a, so let's just ignore the fractions first. But okay, so when I multiply these here, I need to change the color. I thought I did already. So I get what? That's going to be b squared. That's over, 4a. And then when I multiply here, that's negative b, and then that's times a negative, so that's going to be b times that whole thing. But then when I multiply it here again, the next time when I multiply it here, it's going to be the opposite of that, so they're going to cancel out. Okay, so I don't even need to write that one down. And then finally at the end, it's going to be a negative, right? And then it just basically cancels out the square root. So b squared minus 4ac, that's all over 4a squared, sorry. Okay, so let's simplify this. So b squared, I can simplify that. That's just going to be, because b squared minus b squared, that's gone, right? So we're going to have negative 4ac. Oh, but just a second, because this is going to be minus a minus. Yeah, minus a minus, so this is positive here, okay? Right, when we go to multiply these in, it's going to be minus, right, b squared minus 4ac. So I forgot to change this to a positive because it's minus a minus, right? So this is now positive 4ac all over 4a squared, okay? So the 4's simplify, this simplifies, the squared simplifies, so I just left with c over a. Okay, so those are just algebraic manipulations of the quadratic formula. And the last one is a little bit more bonkers, okay? So I would say all of these are just unnecessary to do for the assessment, but if you really want, what you could think about is kind of like working backwards with the roots. Okay, so if I know that my roots are, that's where I'm going to get my product and sum, right? We could think about that. Okay, so this one here, where we have the roots here, so you have something like, let's try to work backwards on this one. If we could use, whenever we can use the square root principle, that would be great. So x is equal to 2 plus or minus the square root of 5, right? Now, at some point we're going to have a perfect square. We can try to go backwards. So like I can subtract 2 from both sides. So then when I do that, I have x minus 2, I'm going backwards, right, is equal to plus or minus the square root of 5. And then I want to square that, right, so that I get rid of the square root. So then I'll have x minus 2 squared equals 5, right? So if we have this is like, we could use the square root principle here to solve that, right? And then if I expand this part here, this is just x squared minus 4x plus 4 equals 5. And then when I set it equal to 0, well, I subtract 5. It'll be x squared minus 4x minus 1. Okay? Now, that's using the square root principle, but you could also use it a different way if you thought about, okay, kind of like we did up here, what are the roots? So if I have the roots, what's like, you could think about what do I need to do to get the product and sum? So x squared, and then here's our sum, and here's our product, right? So what I could do is like, well, if I take the roots, what is the sum, right? What is the sum? Okay, so I'd have to look at, well, what is the sum of, if that's the root, the opposite of that would be like -2, because remember the root would be opposite of what the actual product sum part is. Okay, so -2 plus root 5, and I'm going to take the sum, add that there, -2 minus root 5. Okay, so if I add those together, that's -4, and then these part here, they just equal 0, right? So this is our sum. And then when the product of those, when I multiply, so I can use, I won't rewrite this, but I multiply here, that's just going to be 4, right? And then here, okay, and that's going to be plus 2 root 5, and that will be minus 2 root 5, so that cancels. And then it would be minus 5. So the product is -1. Okay? So I used the roots. Okay? And remember, if this is the root here, you know, it's going to be x. So if the root was, say, 2, you would say x minus 2. So x minus that part there. Right? And then let's say the first one's the negative, and then the other one will be x minus, and I'll use the plus, okay? So that's just what I did there to find the product and the sum. If I know the product and the sum, I can just rewrite it x squared, and the sum is -4, so -4x, and the product is -1. So that would be kind of like using the quadratic formula mode. And you're not going to see anything like this on an assessment. This is really, really stretching it. But if you really want to kind of push yourself, that's fine. That would work.